Hello, CS112. Today I'll be going over a quick solution to Lab 10, which has to do with file I/O. The gist of this assignment is that you are going to be given a file in a CSV format as described on the assignment PDF, which would look something like this. I kind of just typed it up here. And you were to gather the information from the CSV file and write to a text file the BMI of each person. So for instance, I believe this would be your input CSV, and then your output would look something like it would be the name and the calculated BMI. I believe this specific test case results in 2.55. And they also gave the formula to actually calculate this BMI. So inside of this CSV, we really only need the height, weight, and the name, obviously, for formatting. But you were to take the weights as your numerator and divide it by height squared. And that is how you would result at the actual BMI. And you could have CSV files with more than just one person. In fact, you will. I have the 3 test cases out here that we will go through later, but you can have multiple names, but it would just be a list of longer people. So like you could have, Adam and like 1.1, 3 or something like that. You could have a variable amount of names. So that's why it did mention that you do need to use a for loop to calculate this, because you can have a variable amount of people in this CSV file. Excuse me. So, choking on my saliva here. So first things first, I have downloaded the input files directory off Blackboard, and I've unzipped it, and it comes with these 3 files, 3 input CSV files, and I have created my own Python file in the same directory as these guys, so that's why we can all see them together. If you wanted to see what's in your current directory and you're using Windows or the command prompt, you would just type in dir. That's what ls is. I'm just using git bash, but anyways, so to dive right into it, the very first thing I'm going to do is I'm going to open the files I want to work with. So for my input file, I'm just going to say input file equals open, and I'm going to open the input path in the reading mode because I want to read from the CSV file, and that the CSV file is going to be passed in here. As you can see, I've already typed out input 1, 2, and 3.csv, and it's important that you make them a string because that's what Python's expecting. So this is a string input CSV file here, and I'm reading from that. Then I'm going to want to open my output file. So I'm going to open output path. So the path to the output file in writing mode. Now something to keep in mind about writing, so W and appending A, those are different. Appending will simply append to the file if it exists, while writing will completely overwrite it and change the file. So it will delete all the contents and then start writing from scratch, which is what we're doing in this case. And something else to mention is that when you are opening a file to write to, it will first check the current directory to see if this file exists. If it does exist, then either append if you're using A, or just completely delete all the contents and write to it. If it doesn't exist, then it will create a new file with the name of whatever you're specifying here. So that's something to keep in mind about opening files here. And then let's just go right into it. So when I personally work with file I/O, I always like to just make my stuff into a list. So make my input file into a list because I know I can work with lists very comfortably. So I'm going to just create a new variable called input list and input list, and set that equal to input file dot read lines. So what read lines does is it will just take whatever input list, or sorry, we'll take whatever the argument is right here, and it will make it into an array where every line is an element in said array. So now if I were to, let's say, iterate this, so for I in input list, and to print out I, what would happen? Well, let's find out. And let's only use one of these files while I go through the first one. Let's use 2 since it's has a couple lines in it. So if I was to run this now, so pi cat. So I is going to represent every single line in the array, or line in the file. So I's first is going to be the you know, the sort of title column at the top, or a title row at the top, and then you have the actual data below it. So let's start formatting this so it's a little easier to work with. The first thing I want to do is get rid of this line because I don't want this in my actual output. This has nothing, this doesn't help me at all. So something I can actually do here is before I or before I create a list of input file, I can take input file and just skip over the first line, because since I already know that input file's first line is going to be just the headers, I can get rid of that. I don't actually want that in my calculation. So I can take input file and set that, or it's not set that equal, just say read line. So let me open up real quick, just so we're all on the same page here. Input, what is it called? Input 2. Okay. So input2.csv, if I was to open that up, when you first create input file, that is going to create a quote unquote pointer that is going to point right to this first line here. So you can imagine like an imaginary arrow just pointing to this line here. The second it says read line, it is going to read that line and just move on to the next one. So now it's waiting at line 2. So now this variable input file is waiting at this line 2 to start working. Line 1 will not be read again. So that's why simply saying read line, we'll skip over this line and it will go straight to the next one, which is what I want to do. I just want to skip over that first line. And then I create a list of what that file pointer input file is pointing to. So in this case, it'll be at line 2 and everything below it. So that's what read lines is doing there. And so now if I was to save this and run it, let me close that. So save this and run it. So first I'm just going to remove output2.txt. So now if I was to save it and run it, we no longer have the headers. We only have the information we need. So now I want to actually format each of these to look a little prettier. So one of the things they suggested that we use is a function called split. So I'm going to use split in my solution here, where I'm going to take I and split it at the commas here. As you can see, each piece of information is separated by a comma. So now what would this look like if I printed out I? It is going to be a list where each element is one of the numbers, which is exactly something I can work with directly in my writes. So we know that the name is at the 0th index, the height is at the 2nd, and the weight is at the 3rd. So I can start calculating here. I'm just going to get this down here so I don't have to keep scrolling up and down. I'm just going to make it a comment right here. So the very first thing I want to do is I want my output file to write the name, because that is the format of our output file. So I'm going to say output file dot write, and then the name, which is at I0. And according to my little thing up here, it's going to be the name and then a colon with a space after it. So I want to format that nice and cleanly here. So I'm going to say plus colon and just add a little padding there. So I can directly concatenate it here because by default, everything reading from a file is a string. So now to get the actual numbers here, I'm going to say BMI equals float, and it's the numerator of the numerator is the weight, which is at 0, 1, 2. So that's going to be float I2 divided by float of, it's the numerator is weight, which is at 0, 1, 2, 3. Had a little brain fart there. And then the denominator is height, which is at 0, 1, 2. So this is float of I2. And I want to square that because it is the height squared. So right here, I'm going to square it. And then I want to actually write that. So I'm going to say output file dot write, and I'm going to write what? I'm going to write BMI, and I want to make that a string so I can add a new line to it. So plus a new line. So the reason I want to put a new line is because we want each of these in our output.txt on a new line. So now if I were to run this file, let's just run it really quickly. Am I printing anything? I'm not good. So Now, like I said before, so if I was to display what's in this directory, we just have my cats, we have input 1, input 2, and input 3. I'm actually just going to remove output2.txt. So now we only have these 3 files here. As soon as I run this file, py cat.py, and I was to list out my directory again, output2.txt was created. So the test case I'm running right now, it was passed in output2.txt as the file name, and as soon as open was called on it with the rights, it searched my current directory, the output path, and then since it wasn't there, it created that file for me. So if I was to just open that up real quick, output2.txt, we can see that we need to round our numbers, but we have gotten the right format and the right numbers. We just need to do some rounding. So something interesting I'm actually going to, I'll just open it back up, show you guys if you're working with file IO is you can directly, what's happening here? Okay, no idea what that was about. You can directly see live updates as you run this file. So obviously I need to round BMI, so I can just do that directly here. So I'm going to round BMI by 2. So if I was to save that, and I was to run it again, so py cats, this was updated automatically. So yeah, as soon as you run it, this will automatically be updated. So now just to run it with the rest of the test cases, just so we all get a feeling of what's going on here. As you can see, I'm going to show ls again, and right now we still have output2.txt, the 3 CSV files, and cat.py. But as soon as I run it, we now have all of the output.txt files because that's what I wanted to name them. And you can name these literally anything you want. So if you wanted banana.txt instead of output2.txt, you would run this, and now you have banana2 created right here. Output2.txt would technically still exist, but now just to test what output1.txt looks like, that should be Jessica with 20.55 and code of output3.txt. That is going to be the last test case. And as you can see, I got the expected output. So, whoopsie daisy. So yeah, this is the solution right here. Again, for me, it was easiest to put it into a list, and this is a helpful method right here to just skip over the header file if that's not part of your calculation. Oh, I'm sure some of you guys were screaming at the screen or yelling at me for forgetting to do this, but we always need to say input file.close and outputs file.close. That's something that's very important to do. You guys will learn about why later, but yeah, so this is the solution right here. If you guys have any questions, do feel free to let us know. But it is good to play around with like opening files and writing to them in live time, especially for upcoming projects and the final exam.